So for this video, we're going to be talking about potential energy, a potential energy equation, and then also just a little bit more about integrals. So we'll start off by talking about the definition of potential energy. So potential energy is the energy possessed by virtue of an object's position relative to other objects. So for example, that would be restoring forces such as gravity or springs. Like if an object is held up and the potential energy is the energy potential that when the object is released, it'll just fall down. Or if a spring is compressed, the potential of a spring to be compressed, stuff like that. So now we'll talk about a potential energy equation. So we can write potential energy as U. Potential energy U equals negative integral of f dx. So we're going to want to remember that. That'll come in handy. And now we're just going to talk a little bit about integrals. Of course, let's just review. One way to find an integral is, say they give us the graph of force, F, and this is X. And let's just say it looks like this. A way to find the integral on the given interval is just by measuring the area under the curve, right? So that's always going to be positive if we're just going by area, because area like this won't be negative. So now we're going to go to the problem. I'll show it here, number 29. So the graph above shows a conservative force Fx is a function of position x acting on an object in a closed system. If this is the only force acting on the object, what happens to the potential energy of the system as the object moves from 0 to 10 meters? So all we have to do to find the potential energy of this system is just use this graph, of course. So first thing we're gonna do, so we know that all we have to do is look at the graph, which is right here. I'll draw a little diagram right here. So I think it looks just like this, and here, yeah, just like that. And this is 0.1, 0.1, and that's 0, of course. And they're asking us to find the potential energy, and this is force, and this is x. They're asking us to find the potential energy. So all we have to do is look at this and find the area of the curve. So that's all we have to do. Now, some people might be confused because they say, oh, this area is below the, it's in the negative y, a quadrant with negative y values. But it doesn't matter because it's area, and the potential energy can never decrease because it's the further we go, the more positive area we're generating, and area can't be negative. So the integral is positive, right? Integral is positive. Right? We see that. So now the final thing we're going to talk about is just that, just review that you can also just remember the potential energy negative derivative of f dx. So we see that the integral and the amount of area is always increasing. So now we can take a look at our answers, and we see that increases only, and area can only increase and can't be negative. So we know that A is going to be our correct answer choice.